Okay, sorry for the waiting. What will happen right now is like we finish the brief Python, so we basically go over the Python once. Okay, the first 4 week we kind of doing that, and then starting from today we will have a new class shell that is uh, called Python Programming Essential. So you will see a new course, Python course on your course share. The homework was starting from here. So it actually is this one. We are going to take this one now. So let's go into this course now. So this one, there is a textbook called Janglera 3.0. You can download this file, okay? So after you download, you should see something like this. This is the textbook. I'm sorry. This is the textbook that we are going to use called Janglera. So what happened is like the brief Python, we go over the Python language once. And then now we are going to teach you Python programming now. Okay, more seriously go into Python programming. So a lot of detailed things will involve in Python programming, including graphic, data science, and kind of a lot of issues. Okay, not just the language itself. So this one will teach you chapter by chapter. So what will happen is the chapter 1 to 4 is similar to the Python essential. So here on the right-hand side, your homework would be chapter PE is programming essentials. This one, first week, homework chapter 1, 2, and then 3, and then 5, and then 4, and then this is the homework chapters, okay, from the John Lera's book. And then the extra topic right here, we may jump over different extra topic, okay? Some of them not in the textbook, okay? Some of them not in the textbook. The whole purpose is to teach you how to process the data and put them into the data visualization tools, and also teaching you database and JSON, okay? So those are our purpose of studying Python for data science. So we will be teaching primarily using the John Lera textbook with some extra material on Python data processing. Okay, so that is our plan, and usually we will finish this course before the end of uh, August, and then starting from September, we will teach you web design. That will be teaching you HTML and JavaScript. So maybe Vienna will stay. Other students, maybe they will move on to other course. Okay, it's okay. Okay, now let's actually go back to our material. So I'll go over the chapter faster because we already know the brief Python. So here we are going to talk about some of the main computer science related issues. Okay. So chapter 1 is on computer and programs. Okay. So computer and programs, here we would like to teach you what is the hardware and software in a computer system. Okay. And then we need to know about what computer science with scientists would study. So these are the basic issues. Okay, and also know about the computer programming languages, main functions. Okay. Okay, so this one, and we will also talk about random numbers. Okay, so this is the chapter 1's main purpose. Basically, talk about what is computer hardware, software, programming language, and random number. Okay, so this part is not hard. We won't spend too much time on this chapter 1 because it's kind of like a review. So, first one, our current computer is called universal computer. Okay. So let me ask Sherry, what is universal computer then? Universal machine.
Like a machine that's like a computer that's I don't
So
know
you
really.
have an Intel CPU, right?
Yeah.
We call it universal machine.
Mhm.
But if you have a, let's see, if you have a air conditioner and they have a microcontroller, that microcontroller control the AC, but only used for AC. This is not universal machine. The universal machine that we talk about is the machine that we can program. We can write program on it, then that is a universal machine. If the controller is not programmable, we call it ASIC, application specific IC. Okay? Is that okay?
Yeah.
So AMD, Intel are creating universal machine, while NVIDIA is creating GPU, graphic processor, right? So who is working on ASIC? Broadcom is working on ASIC. Okay, so these are different company, they work on different things. Right here, we are talking about how to program the universal machine, okay? Okay, so a program is the program that you teach the computer what to do, okay? So it can be machine language that's lower level, it can be higher level language like a Python language, okay? Okay, that's a computer programs. So program is queued and carried out. Okay, so there is a hardware that can work on it. And software is a program, is the rules, and then hardware is the machine, okay, the thing that do programming for you. Okay, so you need to know what is hardware, what is software. Okay, computer science is the science of the computer. Okay, so it's to study problem solving. So I think this one everyone knows. We won't repeat it too many times. Next one, the term algorithm. Algorithm is a known solution to some problems. Okay. Okay, this portion we will just go over briefly. And then hardware, basically you have a CPU, you have main memory, you have input device, output device, secondary memory. Secondary usually is the hard disk. Okay. So you need to know about this chart. This chart, you need to memorize it. Okay. Liana, are you okay so far? Hi, Liana.
Yeah.
If I am going too fast, you need to let me know, okay?
Okay.
Because you just start learning computer, I sometimes go in too fast. Central processing unit is the brain of the computer. So Intel processor is actually the one that carry out the instructions is the central processing unit, okay? Here, this one just go over quickly, so we won't spend too much time on chapter 1, okay? We will quickly go to chapter 2. Okay, memory is to store data. Okay, so you have memory. Memory usually is DRAM, and then when you unplug the power, then the DRAM will be completely gone. Okay, the data will be lost. And then secondary memory like hard disk, when you unplug the power, the memory still stay. Okay, so those kind of memory can do long-term storage. It's called hard disk. Okay, input device including your keyboard, mouse, these different things. Output device, you have printer, monitor. Okay. And your computer goes through the fetch execute cycle. You get a computer instruction from memory, and then you decode the instruction to see what to do. And then we work out the action, and then the result is stored back to your memory. Okay, so this is the called instruction cycle. Okay, this is a instruction cycle. Okay, programming language is you have the natural language and you have low-level language, you have high-level language. Natural language is like English, okay? Everyday daily language, let's call natural language. Programming language is the language used to program the computer. Okay, including the syntax and semantics. Okay, anyway. So high-level language like Python is a high-level language, and machine code is low-level language. So machine code is basically binary 0110, this kind of binary code. Okay, high-level language is the Python language that we know, A equals 3. Okay, these are the differences. Okay, this okay. So this is from hardware to high-level language. Okay. So high-level language is you have Python language or Java language, that's a high-level language. So you have high-level language, let's assume this is C language. You compile it to some machine code. Okay, so you have 10110, those kind of machine code. And you have some input data and the machine code got wrong and you got output. Okay, so this is how it works, but it goes through a compiler. Compiler actually compile the whole program into the machine code. Okay, that's one way to do it. An interpreter like Python is using interpreter, so interpreter is different. Your source code and data sent to the interpreter at the same time, and they will deliver the result right away. Okay, and translate the language command by command. Okay. Okay, that's the difference between compiler and the interpretation. I talk about this because some of the homework you will need to know about this, okay? So compiler is the whole chapter translator, while interpreter is sentence by sentence translator, okay? This is the difference. Okay, magic of Python. So this one start to talk about programming language. So Python, you go into the environment. Okay, this part is introduction. We'll skip. Okay, so go into there. You can print hello world and then print data. Okay, we all know about this. And then you can define a function. Okay, this okay. We'll quickly go over it. Okay, this portion I think everyone is fine. So we are not going to waste time on this. Okay. Okay, first program is called chaos. This chaos program is to create random number. Okay, let's talk about data. Let's talk about data now, okay? So you have 1, 2, 3, 4, 5. These are numbers. Okay. So you may have A, B, okay, equals 1, 3. Okay, Sherry, what's this? This is, huh?
Like the point.
When I write A, B, and there's an arrow on top of it, equals 1, 3, what's this? What does this call in math?
Like array?
In Python, it's called array or list, yes, but or you can call it tuple. But in math, it's called vector.
Oh, okay. Yeah.
Okay. Multiple data. So this tuple is a vector. So what's the difference between vector and single value? How about Iena? Do you know what's the difference between single value and vector? Did you know vector or no? Hello? I did not hear you. You say something, I see your lips move.
Oh, yeah, I know what vector is.
You know what vector is? Okay. So basically, let's assume that you have the XY domain. You put a certain point of the 3 and 4, That's a tuple, that's also a vector, okay? So a single value, we call it a value. Multiple value, we call it vector, okay? And you may have a vector of multiple tuples, 3, 4, 5, 1, 7, and many. This we call it an array, right? So this we call it an array. Okay, these are different data. And then, so we have a single point, we call it data, or we call it a scalar data. Scalar, okay, SCALAR, okay, scalar data, that's one data, 3. We may have a point that is 3 and 4. We call it a vector. It's actually a 2-dimensional data. Okay, then we may have 3-dimensional data. Then we call it tensor. And then 4-dimension, 5-dimension, or extra dimension more than 3-dimension, they all can tell us tensor. They all call tensor. Okay. So more than two-dimension data, we call it tensor. Okay, that's actually search for internet. So they are tensor. Okay, so you see tensor here, image. Okay, so here show you one data is called 1D tensor or scalar. 2D, actually 0D data is called scalar. Okay, or call it single variable. Okay. Okay, 1D tensor, we call it vector. So tensor is a general term, can be 1D, 2D, 3D, 4D, 5D, 6D, 7D, any number of D. Okay, any number of dimension. 1-dimension data is 0-dimension data is called scalar. That's only one variable. 1-dimension data, we call it vector. Sometimes we also call it array. 2-dimensional data, we call it metric. Okay, 3-dimensional data or more, we all call it tensor. And in AI, we process larger dimension of the data. So that's why people call it TensorFlow processing. Okay, you say TensorFlow processing, there are tons of the diagram that will tell you what TensorFlow processing is. And then Python also have a package called Python TensorFlow. There's a logo called TensorFlow. You can search for Python TensorFlow. So for AI, you need to use TensorFlow. Okay. And then Google has the tensor process. Google actually has a tensor processor. Google Cross Tensor Processing Unit. Okay. And then Google Tensor 6 processor is a processor for their Google's AI processor. Google Tensor, okay. Pixel 6 chip, Tensor chip 6 chip, okay. So Tensor processor is used to process the AI, okay. Why am I talking about so much of these? Just because I'm going to tell you, we starting to talk about what is a single variable, talk about what is scalar, one data, and later you are going to process array, vector, then metric, then tensor, then higher order data. That's the whole bunch of the data you process, and that's called data science. And you use the AI to process it, that's artificial intelligence. Is that okay? Hello, is that okay?
Yeah.
Now, next one, we go back to our topic. What is chaos? Chaos because we actually have a random variable. So a variable x equals 1 or x equals 7 or anything, this x is called a variable. A variable is a unknown value that can have different value. Okay, so x you can assign any value to it, so we call it a variable. Now, there is something called random variable. Random variable. So Sherry, what is random variable?
Like usually you give like a range maybe, and then you just use like the random variable like function, and it will generate you like a random number between the range you gave.
But what is the difference between variable and random variable?
Like a variable is
A variable is a unknown variable with changing value, right?
yeah.
And then what is a random variable? How about Iena? Do you know what is random variable?
It's like a value that's like random, and that's from like a random process, and it's not like a variable, because for a variable you can like choose
It is
the
available.
number.
It still is available. We call it random variable. It still is available. But it's available with probability. When there is a variable with probability, we call it random variable. Let's look at it. So let's assume that we have a x value. X value can be 0 or 1. 0 means tail. 1 means head. So this x is a random variable because your 0 is 50% chance. 1 is also 50% chance. So your solution space for x, you may have the 0, you may have a 1. The probability function of this x will be 50-50. Same value, 50-50. Then we call this x as a random variable, but it comes with a probability of 50-50. So this x value is defined as 0 or 1. These two possible values, this is the set that it has. Let's call it binary set. So x will be belonging to this binary set, 0 or 1. 0 means tail, 1 means head. Each one of them has 50% chance. Okay, sometimes you may have a biased coin. So maybe your head is 60% and your tail is 40%. So that probability may have different distribution, but the solution space still only has 0 and 1. Got it? Hello, got it?
Yeah.
Sherry, is that okay?
Yes.
So in a way, x defined in the binary set 0 and 1, just like your normal algebra, your algebra may have integer, so your integer can be 0, 1, 2, 3, 4, 5, 6, 7, any whole number. So that x belonging to the whole number that actually is g, that's integer, right? So it can be any number in the integer that's your domain. That's your domain. So that's the regular variable. Now you may have a random probability, say your probability like this, okay? From minus infinity to infinity, you may have a Bell structures distribution for your value. 0 giving the highest priority, plus or minus is actually lower, so that have probability distribution. Then this X is a random number. Liana, is that okay?
Yeah.
So when we do calculation, we may want to mimic the random events. Okay, so now if I post my X, I may have 50% chance of getting a 0, 50% chance of getting a 1. Then my computer need to simulate it. Let's do this simulation, okay? Let's do this simulation. So today I'm talking about random variable, okay? I'm actually talking about random variable. So we talk about random first. So random, let's go to our, so I'm reviewing the chapter 1 in a way, okay? But I just go to the more difficult topic, okay? I don't go over the basic one. So right here, I'm going to go over the generation of random numbers directly, okay? Here, as you can see, I'm not using the one. I'm not using the so-called idle anymore. Let me close it, okay? Let me redo it. So you have the Visual Studio Code, you double click it, okay? You bring up this environment. There may be some directory, we don't care. Let's open a new folder. Okay, go to the directory you want to have. So right here, I'm CS31 Python. Let me continue to use this one. And then Python development, let me create a new one. Okay, because I'm going to, the PyDY development is for the brief Python. So I'm going to change it to a new directory called Python data. Okay, Python data science. So use this one. I'm going to create chapter 1. Okay. I go to chapter 1. I actually will create a new file. So I select this folder. So this folder right now is empty, no file. So let's go first one. Let's call it coins.py. Okay, so this one, let's call it coin.py. The editing is the same as the idle, but right here I'm going to do sharp coins.py. Okay. Okay, this header are all comments, so of no use. Now we want to simulate the event for random numbers, so we do import. Let's do import random. Okay. We import random in. Okay. Then I'm going to try 10 numbers for I in range 10. Okay, that's X equal random. Random is the module that random. Okay, random, second random is a function name. This random is a module. Okay. So I have the X and then I print it. Okay, so first one I introduce this function called random.random function. Okay, random.random function, and that's the run it. Okay, so random.random function will generate a value of 0. It will generate a value of from 0 to 1, but not including 1. Okay. Is that okay? Any questions so far?
No.
This is random function, okay? Now, next one, let's call it random integer. So for I in range 10, x equals random, that random integer 1 to 10, print x. So this one would generate a value from 1 to 10, including 10, okay? Oh, I'm sorry, random, there's no 10, okay, just run it. Okay, so that's 1 to 10. So these are something that we know for random. Okay, now these two I just show you the random value. Now I want to mimic the process of generating a coin of 50-50%, right? 50-50%. Now I want to create a coin of 50-50%. So what should I do? Let me actually, so this portion I'm going to comment them out. These are of no use, so I'm going to comment them out, okay? Later you can keep them and run them. But at this moment, I don't use it, okay? So this we are commenting out with using triple quote. Okay, these are of no use now. Now I'm going to generate a value that actually is 50-50%, okay? So I'm going to do for I in range 10 events, okay, and then I create x that is random. If x less than 0.5, then print tail, else print head. Okay, so this one simply give you a simulation that this x can be 0 or 1. Okay, right here you can assign as a 0 or 1. Okay, because it's a head or tail. This is the way to generate, and each one of them have 50%. Okay, 50%. So that's a say, and that's wrong. And they'll tell you head tail combination. Any questions so far? Any questions so far?
No.
No?
No.
Okay. So let's see. I can define a function. Okay, I can define a function. This one is called toast function. Okay, toast function. And then x equals random. Random. If x less than 0.5, return 0. Otherwise, we return 1. So this toast would return either 0 or 1. Okay. So here, let's change it. Let's change here to polling toast. And if the toast equals 0, we print tail. Otherwise, we print head. So this one will create a random value of 0 or 1. Okay. And that will give you the head and tail. Okay. Any questions so far? Okay. So we first talk about what is random variable, and then design a random variable that suiting it. So right here, you may change this one to 0.4. When you change it to 0.4, then what will happen is your 0 will be 40%. Your head be 60%. That's actually wrong more. No, don't wrong 10. That's wrong 100. And then this one that's changed to 0.2. So only 20% of the tail and 80% head. Let's save and run this one. So you should see more head than tail, right? Many more head than tail. So it's 8:2 ratio of head to tail. This is how to simulate a random event, how to create a random variable. Okay, any question? So far, okay?
Yeah.
Okay. Now, this is random variable. So random variable, let's go back to random variable. Random variable is a variable with probability. Okay, let me talk about it one more time. It's the same as a variable, but they do have probability on each solution space. Each value of x 0 or 1 may have some value associated with it. Now we call it random variable. Okay, so your domain, let's call it B binary, is this set, okay? And your x is actually defined in B, okay? And B comes with a probability distribution function P of x. Is okay? And P of x equals actually 0.5 if you x equals 0, and then 0.5 if x equals 1, right? This is the probability distribution. Does that make sense?
Yeah.
Liana, are you okay?
Yeah.
Liana, are you okay? Have you learned some probability before or no?
Yeah.
Okay, make sure, okay? I'm kind of maybe a little bit reviewing math for you. Okay. So now we are going to talk about something else. So leaving around here, we are going to talk about random sequence. What is random sequence? So now let's assume that I have 10 toes, and you have S0, S1, S2, S3. So you tossing it for 10 times up to S9. So you tossing it for 10 times, and each one of them can be 0 or 1, 0 or 1 based on the probability distribution. This one, we call it a random sequence. Okay? So sometimes you need to simulate the random sequence. Let's look at how random sequence can be done. So we do have a toast function, we do have visible one, whatever. Now let's look at random sequence. So random sequence, okay, is defined as toast function greater than less than 0.5. Okay, you will get 0 if, okay, else you get 1. So this is single toast. Single toast, you get 0 or 1. Okay. And then for I in range of 10, so you toast for 10 times, and you create a random sequence, and that's a pretty random sequence. Is that okay? Now, I want to have the tail sequence. Is that okay? Now I do traversal over the random sequence, get every data. If it's 0, I create tail, otherwise I create head. And let me print this tail sequence. So head, tail, head, because this function right now is 80% head. Is that okay? So this is random sequence. Okay. So this one I domain is 0 to 9. And then each one of them perform a toss. So toss will be 0 or 1 on each one of the random sequence. And 0 means head, 1 means 0 means tail, 1 means head. 0 means head, tail, 1 means head. Okay, something like that. This is how we define from X to the sequence. Okay, that's a random sequence. So we talk about a lot of the random variable, random sequence, random domain. Okay, go back to what we want to have, chapter 1. So here is talking about how to create a random function. How to create a function that will generate 0 to 1. Okay. Is that okay so far?
Yeah.
So how to create this 0 or 1 function? Here, I mean, in the textbook, they are kind of using this function. Okay, you do see this chaos function. I'm sorry, let me check for you. You do see this chaos function. So why here you use this chaos? 3.9 times x times 1 minus x. Why this function is like that? Why this function can generate number from 0 to 1? Okay, in this textbook, we keep seeing this function many times, chaos the p1. Okay, so why here it uses 3.9 times x times 1 minus x. Actually, this is 3.9 should be 4. It's 4 times s times 1 minus x. Okay, what this function is, let's look at it. First, let's look at this function. Y equals x times 1 minus x. Okay, it will be minus x squared plus x. Is that okay? So far, okay? So you'll be equals minus x squared plus x minus 1/4 plus 1/4. It is equal to minus x minus 1/2 squared plus 1/4. So what is this function? This function is a function that is peak at 1/2. When you have 0, you go to 0. when you have 1, you will also go to 0. So this function look like this. It says a parabola function like this, and peak at 1/4. Okay. So if you do x times 1 minus x, maximum 1/4, minimum 1, that's not what we want. So this whole thing times 4. You become a function from 0 to 1, peak at 1 is a parabola, and the peak is happening on 1/2. So let's assume my x is going from here to here. My x going from here to here. So given the x, I calculate 4 times s times 1 minus x. I should get a y. So that's assume that, for example, I put a certain value and I get a y. And the y will be my new x value. Next iteration, I use the y value right here, and you shoot for another new y. And then the new y actually will go to maybe here, and you will shoot for a new y. And then the new y come here, you shoot for another new y. And keep doing that, the value will be always between 0 and 1. And that would be the chaos function that you want to have. Does that make sense? Does that make sense?
Yeah.
So this chaos function just give you an experiment of using a parabola function to generate the so-called random values between 0 and 1. Let's actually try it, okay? So this is the KR function. Let's try it. This one is called it chaos 0 the P1, okay? Okay, so for I in range 10, I do 10 times of such an experiment, okay? And right here before it, we actually do print, enter a seed value. Seed is the initial x, okay? So it actually initial x, okay? So x will be equal to input function, but you need to convert it to flow number. Okay, and this number is supposed to be from 0 to 1, but not including 0 to 1. Okay, any value between 0 and 1. So you got an x. Now, the new x, so you will actually print your x. Then the new x will be equal to 4.0 times x times 1 minus x. So far, okay? Given an x, you get a y, and the y will be used next time for the next x. So by doing that, you actually creating the sequence that we talk about. Peak value at 1, from 0 to 1, peak value is at the 0.5. Then you will shoot here, get a new value, shoot here, get a new value, should here get a new value, should here get a new value, and then the value will be changing from 0 to 1. Okay, suppose. So that's actually wrong for it. When you run, you say Python chaos 0.p1. So given the value between 0 and 1, let's use 0.77. So 10 random numbers are generated between 0 and 1. Is that okay so far? Now let me run one more time. But I enter 0.5. And it got stuck. That's a problem. So 0.5 doesn't work. 0.5 means you come here, you shoot for the peak, you get a peak, you go here again, you go to here, go to the peak, you go here, go to the peak, you go here, go to the peak, you actually never get out. Is that okay? I'm sorry, actually it's not. You go to the peak, and the peak come here, you actually get 0. Get 0 and it's always 0, stuck at 0, no longer random. Is that okay? Hello. So this function at the 0.5, this is sparky. So that's why let's copy this one. In order to avoid this problem, we have a chaos.py. Okay, so let's do this. Let's have the chaos.py. So let's put it over here. So how about this? Don't use a 4. Let's use 3.999999999. Good enough? I don't want to use 4. I use a 3.99999. So let's run this one now. Let's run this one. Python chaos.py. 0.5. I think too many 9. Maybe they wrong off. Let's don't try so many. Try again. Too many is close to 1. That usually is of no use. You solve the problem. Okay? Does that make sense?
Yeah.
So this one will give you 0 to 1. So that's why 3.9 is used in the textbook. But this 3.9 actually is somebody close to 4, but not 4. You can use a 3.999, 3.9999, actually whatever number you want to pick. That will always work. And then they are based on such a function, the parabola function that we talked about. Okay? It's based on that parabola function that we about. And in a way, it will generate a random number between 0 and 1. Okay? So this one in the text will show you how random numbers are generated. Basically, this one is how they create a function for random function. And random direction, how to use it, we already tell you in the coins function. Okay, we already tell you what they are. So here we give you a very good introduction of the chapter 1 for the chaos function. Okay, then you can read the textbook and finish the homework. Okay, does that make sense? Other easy stuff I don't cover. Okay, I don't cover those easy stuff. Let's finish that. Let's go to chapter 2 then. Okay, that has a 5-minute break. Come back on 9:03. Now it's 8:56. Okay. Okay, 5-minute break. We'll go back to chapter 2. Okay. in a break, okay, you can walk around, okay? You don't need to stay here. You can walk around, come back later, okay? Hello, I'm back. So chapter 1, we talk about single variable and single random variable, okay? Now we are going back to here, and as I promised, we will focus more on, we'll add a little bit of the sequence and list right here in chapter 5, okay? Today we are going to cover a little bit of that. And our purpose right now is not teaching you algorithms. The algorithm we will teach you in APCSA course. That's a separate programming course. Here we more focus on data and data science, okay? And here, this chapter 2 is to teach you to write simple programs. Okay, and it will teach you different module and organization of program structures. So before we go that actually look at let's continue for the data sequence. Sherry, are you okay so far?
Yeah.
Let's look at the data sequence now. So now we are going to create sequence and functions. So let's assume that we have a value. The value actually, a single value is X. They have come with some value, right? But sometimes you may have a Y equals sines X or some kind of f of X, right? So your X is from 0 to 1 maybe, and your Y is over here, right? So this function X and Y, you can use a function to define it. So define a sine function of X, and then you return certain value for it, no matter how you generate it. You can also sample it to different points. And that we call it sequence. Okay, that we call it sequence. Now, we are going to focus more on the list and sequence now, okay? We're going to focus more on sequence now. So let's actually look at this one. Let's call sequence 0.py. Okay, sequence 0.py. Okay, number one, I have a sequence, and this sequence I would like to put 0, 0, 0, 0, and I would like to put 10 of them. How could I do that? If I want to put 10 of the 0 in there, and I don't want to type out all the 10 zeros. So Sherry, how can I do that?
For loop,
If I don't want to use for loop,
like multiply.
multiply by 10,
Yeah.
not like this. You do 0 to multiply 10, what will happen?
Oh no, yeah, that won't work.
That will become 0 and only one element 0, okay?
Yeah.
That would be one element 0. You want to create what 10 of these is like this.
Yeah, that's possible.
Okay. So this will, you will print 10, 0. Yeah, now is that okay so far?
Yeah.
This is creating 10 of them. And if you want to change it, you can change it. That's actually, let me give me this, this is so-called chaos function. Let me rewrite, okay? Let me rewrite it. So let me actually have this one. Define chaos. Okay, and then let's have a x. So y should be equal to 3.999 times x times 1 minus x. and you will return y. So given the x, you will return y. Okay, that's the new format of the chaos function. So we using a b x, then let's starting with the seed equals 0.75. Okay, and then you should have a y equals chaos of the y. Okay. No, let's just use y. Okay, don't use a seed. Seed is actually too complicated. Okay. Okay, something like that. So if you don't like to this one to have this value, let's actually do this. Let's actually don't print it. So let's actually let's actually have a function. So this pre-run function, let me have a pre-run function. And this pre-run function will run this sequence. Okay. So that's pre-run for 100 times before we use the y. Okay. So let's do pre-run. Okay, so pre-run would actually make the y already go through many times. Okay, y goes through many times. Let's actually take this one out. Make it a global variable. Put it over here. Okay, so y actually is a seed. But when we pre-run it, it already take many times to run that chaos function. Okay, so we set this and then we say for I in range 10, okay, the 10 should be the length of the sequence. And then the sequence I should be equal to chaos of y, okay, and then y equals sequence I. Is that okay?
Yeah.
Then you will create several sequence member, and all of them would be from the chaos function. So this one update each value for the sequence. Originally is 0, now actually been assigned with the chaos values. Pre-run is reference local variable. Here, let me call it global. Y, okay, make sure this Y is global. Any questions so far? Any questions so far? This is to create a random sequence. Any questions so far?
No.
No.
Okay, now we actually learn one more thing called random sequence, okay? Okay, anyway, this is just want to use the chaos function. Now let's go back to our slices. Writing simple function for chapter 2, okay? So you have software development from analysis requirements, specification, design, implementation, testing, implementation. Okay, this is the process of the different stages of software implementation. You need to know, okay? In the homework, you will need to know that. So your program usually is create a design, implement, and then testing, and then maintain the program, okay? Sometimes it's called this V model, from concept to requirement analysis to subsystem design to unit test, unit design to unit test to put them together to have a bigger test, to put them into the subsystem and test, and then put them into the whole system and test, okay? So break down the function to design and then integrate back to test, okay? So there is a temperature converter program. The spec is input of temperature, output is Fahrenheit. So to design this program, we have a temperature program. I think this one, okay, we talked about it before, okay? And then there are a few data type conversion function that convert a string to float, string to integer, string to integer to string, or some value to its value type, okay? What that this value really means, okay? It actually can work as an integer or floating point. Okay, let's look at it. Let's look at it. What is this eval function? So this one called evaluate.py, okay? So you have an input, okay? Enter a number. And then here you can use an integer, okay? And then you have an x equal this, okay? And then you print x. So doing this one, you will enter a number and then you will print it. Print up the terminal, okay? And then you do Python evaluate.py. So enter number 3, okay, no problem. Let's actually try one more. Let's try Python evaluate. But if right here, put in 0.5, what happened? The end now, what happened? What happened is this is converting to
It's not an
integer.
integer.
Then what happened? You will have error.
Error.
Okay, you will have error. So this one, it really only can convert a string to integer. So if we do eval, you will do evaluation and then you will convert to the right format. So we put a 3, it will be 3, okay, and then Python evaluate. We'll put a 0.5, you get a 0.5. So evaluate will evaluate it to the right type. Is that okay? You evaluate to the right type. Is that okay?
Yeah.
Okay, let's try one more time. So here, let's Python evaluate.py. I put a 3, you will say class integer, okay? Let's do Python evaluate.py. And then I enter 0.5, you will say float, okay, no problem. If we do Python evaluate.py, and then I type in garbage, and you will say it actually would would not evaluate to anything. Okay, it will not evaluate to everything. So here you have to make sure that it's integer or that, but this evaluate we evaluate to the right things. Okay, so let's actually try one more. If I have a Python and then evaluate the py, I put in parentheses 3, 4. It actually evaluate to a tuple. So it's not just evaluate to integer flow, it can evaluate to the type that you have, even tuple or even list. So let's do Python evaluate the py and Python evaluate the py, and I use a bracket 1, 2, 3, 4. It's a list. Does that make sense? Hello, does that make sense? So
Yeah.
evaluate basically the string can be a number, can be an integer, can be a floating point number, can be a list, can be a tuple, even can be a dictionary. Okay, so that's very powerful evaluate function. Okay, remember that. Okay, these are 4 data type conversion that we have. Okay, right here I just emphasize on the more important parts of the program. Okay, next one is the module or the function. Module or the function, last time we talked about it already. You have your program module, statement, expression, and object. And module is you have a file that's one module, and each module may have multiple functions. And if you want to check if the main program is this current module or not, you need to use if underline name equals underline main. Remember that? Remember that one? Sherry, are you okay?
Yeah.
Okay, those part I don't repeat, okay? And then here tell you what can be the name of the variable, must be underline or letter or digit, okay? So these are the valid name, but lowercase and uppercase means different things, okay? Means different things. It's case sensitive. Some keyword that you cannot use, such as delete, for, is, raise, assert, this you cannot use, okay? Okay, so far, okay. This I think we covered so far. Chaos function, we talked about it already. So if you have x equals x plus 1, original is 10, this you get the value of 10, and then you plus 1 and write that to x, so x becomes 11. So this one is the same as x plus equals 1. This x increased by 1. You can write it in 2 different ways, okay? Simultaneous assignment that we talked about it already. You can have x comma y equals some value, some comma some value. Okay, you can assign multiple value in one equal sign. Okay, we already talked about it. You can simultaneous assign x plus y to sum and x minus y to d. Okay, that's simultaneous assignment that we know about it. Loop, we talked about it already. Okay. Future project, okay, future project. Now, future project is we have an initial investment of say $1,000. We want to know about after 10 years, what will be the value of the 10 years value. Okay, let's work on this project. Future value project. Okay, I'm not going to use the program right here. Okay. And we are going to finish this chapter after this future project. So let's look at the program. Let's write this one called future val.py. Okay. Let's call it future val 0.py. Okay, so we will first have initial money. Okay, so that's called principal. Principal money equal to load input. Okay, this here you say initial fund. Okay, certain amount of money in 14-point number. And then you will also say your rate. Okay, so this number should be a number between 0 to 1. Okay, but not including 1. Okay, so maximum 99.99%. Is that okay? Hello?
Yeah.
Yeah.
So that's the interest rate. You have the interest rate, you have principal. Now you are going to calculate your money. Okay, so let's do for. Now next one is actually your years. Okay, we want to know how many years we do saving. Okay, and then that's have a y value. Okay, equals 0. Let's do this. Okay, let's do for y in range starting from 0 to year. Okay, for that many years. Okay, so you put in your principal, your let's do this. Okay, let's do this. Let's do 3. Before you calculate the interest, that's actually print out the year 0 principal. Okay, so then you will print year y plus 1 principal. So this is a principal amount should be your original principal amount times 1 plus your interest rate. Okay, I converted 1 plus 1 to here. Now let's look at this one. $1,000, 10% saving for 10 years. Ooh, checking for integer. Let's see. For y in range of the year. This one, let's use integer. Okay, number of years, let's use integer. Okay. Sorry. Is that okay? So after 10 years, if every year you have the 10% interest, after 10 years, you are 2.5 times of your value. Okay. You are 2.5 times of your value. So that's what your the so-called future value is. Okay, future value. Any questions so far?
No.
No, let me rewrite it in different way. So let me rewrite it in another way. This one call it future value 1. So this is future value 1. I get my y here. Okay, I'm going to change it. So my years should be equal to 4 y in range of the year. And I'm going to put the y plus 1. So from year 1 to year 10, okay? And then I got my principal already, and then I'm going to do my principles, okay? Let me see. No, I cannot. So this is a principle. I'm going to use an empty list. Okay, and I say for y in years. Okay, and then my principles equal to my principal times 1 plus rate. So I get a new principal, and then my principal will append that principal in. Does that make sense?
Yeah.
Then I would have my years right here. I would have my principles right here. Up to here, okay? I'm going to do something else later, okay? So initial fund. I'm sorry. I make a mistake. Let me quit. I make a mistake. I cannot use wrong. I have to use terminal, okay? I make a mistake. So let's bring up terminal. Then Python future variable 1 initial fund 1000 0.1 interest rate for 10 years. Okay, it create two lists. One list is years, the other one is principles. Okay, so that's fine. That actually do from PyLab import start. I create two lists. Now right here, I'm going to do this. I'm going to do figure show. Between figure and show, let's do plot year versus principal. That's it. Is that okay? Let me show you a figure of how it grows. Just adding a from PyLab import start. figure show plot this. Is that okay? Hello?
That's
Yeah.
And here, let me close it. Okay. I don't like the plot. Plot is linear chart. Let me use a bar chart. Okay. Pretty, right? Will show you how much money you will be saving over the 10 years. That's what we are doing. We want to teach you data science. And this one is the future value program. We teach you how to calculate the future value for 10 years, okay? And we give you 2 different versions. And we already teach you some brief Python. So right now we are going to teach you the so-called data science. The first one today, let me review it today. Today we starting from a scalar variable. What is X? The next one we talk about what is random variable, right? We talk about random variable. The next one we talk about how to create sequence, random sequence. Then we talk about how to create a random function using chaos random function. Okay, these are the something that we touch. Then we have a sequence, we have random variable. Then we talk about creating X and Y, the sequence value, the years value, and the principal digital value, and then we make plot. That is also a sequence. Is that okay so far? We use the chapter to talk about sequence. That's what we did today. And we finished the chapter 1, chapter 2 review for the Jiang Lera's textbook. Okay, that's what we did today. And hopefully this type of teaching will help you to understand what is data science faster. Okay? So it's beyond programming now. We are not just teaching you the Python language, we are teaching you data science now. Is that okay? So what you learned today, you need to practice by yourself, making sure you know how to make the chart using PyLab, and then 2 sequence, years and principal to plot. If you plot a linear chart, X versus Y chart, you use plot. So linear chart, you use plot. Here we use bar chart. Okay? Is that okay? That's why we learned today, okay? Or we're starting to teach you data science. We use the textbook of the Jiang Lera textbook, but Jiang Lera only teach you programming. We will teach beyond programming. We will also add the data science features into our curriculum, okay? But you will have some homework from this book anyway, okay? Including the chaos function, okay? Okay, that's it for today. See you next time. Okay, bye-bye. Good night. Bye-bye.
Thank you.
Thank you.